How many times per minute does a wheel with a diameter of 15 inches need to spin in order for the vehicle containing the wheel to be traveling 1 mile per minute? Okay, what are your thoughts? What kind of unit of measure are we after? And that means what question are we trying to answer? And we're looking at times per minute to spin. So we're looking for revolutions per minute. And what we have is a linear measurement of 1 mile. So we want to go from a current known measure of 1 mile per 1 minute, and we want to end up with revolutions in that same 1 minute. So where do we start? Any thoughts? Well, the units of time are the same, so we need to turn miles into revolutions. Well, so how many miles are there in 1 revolution? Well, obviously there's not a number of miles, since our wheel is described as having a diameter of 15 inches. Then 1 revolution is going to generate for us a circumference measured in inches. So that's a good place to start. 1 circumference is 2 pi r if we had the radius, or pi times d since we have the diameter. Remember, 2 radii are the same as a diameter. So we've got 15 pi inches in 1 revolution. Now we need to know how many of those 15 pi inches there are in 1 mile. So how would we figure that out? Wouldn't we have to change this 1 mile into inches? Well, do you have memorized how many inches in a mile? Probably not. Hopefully you know that there are 5,280 feet in a mile, which would mean that 1 mile would equal 5,280 times 12 inches, or 63,360 inches in 1 mile. The number of revolutions then is going to be, so number of revolutions is going to be nothing more than how many 15 inches are there in 6,360 miles, or 63,300, I'm sorry, inches, not miles. 63,360 inches divided by 15 pi inches. And notice these are both in inches, and so those are going to cancel. This is how much we've revolved. And if we just reduce the fraction, then we'd have an exact answer, but let's go ahead and round this off to, well, let's say hundredths of an inch. We end up with 1,334.54 revolutions per minute. Wow. Did you expect it to be that large? Think about it. If we were to put, instead of miles per hour, or miles per minute, we had, instead of 1 mile per minute, we had put it as miles per hour. How many miles would we be traveling in that first hour? Well, 1 mile per minute would be the same as 60 miles per hour. So now that's beginning to not look quite so large, don't you think? It's logical. And it's always important when you're working with situations like this that you put it in perspective. You look at it in terms of, does it make any sense? Now I'm going to show you how this calculation is typically done in the mathematics or scientific setting. Many of you may have already seen this, but this is an important little aspect of what we're going to do in analyzing circular motion. So we're going to start out with the one rate that we know. We've got 1 mile in 1 minute. That's a linear measurement, and we want to turn that linear miles per minute measurement into times per minute that the wheel spins. So we want to end up with a label of revolutions per minute. Now think about it for a minute, and hopefully you'll begin to see that if we're using the labels as factors, and we have a particular rate to begin with that we can write as a fraction, and we know the units that we want, RPM, or revolutions per 1 minute, then we can use this relationship right up here and the information we know about the thing that's spinning to multiply our original relationship by successive fractions that will get rid of labels like miles that we don't want and replace it eventually with what we do want. Now, your mind is going to start to jump and question, but go slowly. We've got a linear motion. Linear motion is in terms of circumferences. So we have to actually figure out how many circumferences this is. And once we know how many circumferences, that's the same as the number of revolutions. So our circumference, again, is going to be measured in inches. So let's start by creating a fraction to multiply times this 1 mile over 1 minute that's going to continue to keep the minutes and cancel out the mile. So if I'm going to multiply to cancel out the miles, this denominator must be miles, and I want inches here. Well, we've already figured out that 1 mile is 63,360 inches. So those will cancel, and now if we were multiplying across like we do when we multiply fractions, we'd have our 1 minute in the denominator, but we'd have inches in the numerator instead of revolutions. So we need to be able to get rid of this inches and replace it with revolutions. And since inches is the unit of measure for our circumference, then we know that one revolution, is going to equal 1 circumference. Which means we'd need another multiplication there, and that's okay. Let me just move this fraction over. We'd need now a multiplication, a fraction in there that does two things for us. It's got to cancel circumference. It's also got to cancel inches. That's okay. Don't panic. We're talking about 1 circumference, and we can get 1 circumference in inches. 15 pi inches. So the circumference cancels the circumference. The inches cancels the inches. When we multiply across, we get 63,360 revolutions. We want 1 minute, but right now, multiplying across, we'd have 15 pi minutes. Well, how do we turn that into 1 minute? We know how to do that. If we were reducing this fraction, we'd divide by, and then we wanted to get 1 in the denominator, then we'd divide by 15 pi over 15 pi. We'd divide by 1 in such a way that we'll get 1 in the denominator. So we get our 1 minute, and we get our same equivalent answer. Which was 1,344.54, which we could also write then as, and most likely would write as, 1,344.54